Good morning. Hello, Michael. How's it going? Welcome back.
Thank you. Hey, Alex. Yeah, I just came back from a week vacation, doing not much with the
That's
kids and the family,
uh,
and mostly relaxing and taking walks and runs and doing some archery and board games and
archery. Okay.
Netflix. Yeah, so yeah, I got into archery last year actually around this time, and it's really nice if you're in the middle of nowhere for your vacation, then you can't bother anyone and can't accidentally
Accidentally
uh,
shoot somebody. Yeah.
hurt
Oh,
anyone, and so
yeah.
that was good. Yeah,
That's very
what
good.
a week, right? So
What?
just
Yeah.
got
I
back.
mean, you. Yeah.
It's really unbelievable what happened in the world, and I also yesterday I was at the local demonstration
Mm.
for the Ukraine here in Dresden, and it was quite impressive to see 10,000 people supporting Ukraine and calling for Putin to end the war. And
Yeah.
yeah, so it's been quite quite a shift in a few days.
Yes. Totally. Yeah.
I guess also for us Germans, kind of 180-degree change in terms of like international policy and also like renewable energies and things like that, right? So you kind of see what's suddenly is possible quickly
Yeah.
if the danger is too high, right? So, but yeah, I really hope that for Ukraine they can withstand the aggression and get it resolved and go back to peace and to own their own country. So that would
Hope
be
so too.
really,
Yeah.
really good.
That would be the ideal outcome. Let's see how it goes, but yeah, it's really sad. Was
Yeah,
really shocked initially, and now it's still like, I mean, you you
it's
you
I
go and
can't believe it. Yeah,
no, you watch the news, you scroll through pages, and then it's yeah,
yeah,
it,
yeah,
it's really crazy.
yeah, definitely. Yeah, so
So
what a time to live in, right? So every year you think it can't get worse, kind of
yes,
like
it's
since
true.
since
Yeah,
2016 basically, and it's going
yeah,
downhill
that's right. Yeah, it's a bit
every year.
just about when I thought, okay, now this COVID thing is going to be almost over. It's,
Yeah,
next you know level of craziness
craziness.
starts. So it's
Yeah.
really it's really not good. So yeah,
Let's see. Yeah,
let's
just
see.
crossing fingers that everything works out and that the support from the international community helps to end this war really quickly and put things back to probably not normal, but uh, sanity at
Yeah,
least instead of
yeah.
insanity. Right?
Yes,
Exactly. So
I think that would be good. That would be good.
and that's why I thought perhaps today is also a good time to look at some geodata fitting to the discussions and looking at world borders and things like that. So
Yeah,
let's see.
that's
I
a
didn't
good
have too
idea.
much time to prepare, so it will be a lot of ad hoc and let's try things. But I think that's also
No, I think that's
uh,
good. If you
good for you
yeah,
know
exactly. Good to see what's possible, and it's this is always the spirit of the stream, right? We wanna keep it all
exactly.
going fluid. If you watching this live, let us know in chat what your feeling is currently. If you wanna talk, let us know. If you are wherever you're watching this from, again, welcome. We are diving into Neo4j AuraDB today and showcase a little bit what's going on. And like Michael already said, we want to go into geodata. Let me quickly give you an overview what's generally going on here. So again, discovering Neo4j is the topic. Neo4j AuraDB. This is just a shout out. So Call for Papers is still open for Graph Connect, which takes place 6th to 8th of June this year in Austin, Texas. So if you are interested in presenting anything, let us know. Call for Papers is open until end of March, so you have another 4 weeks or 4.5 or something weeks until that closes. So if you're thinking about it, you know you have a little bit more time, but definitely send something in if you have anything. And the topics are completely wide open, so anything goes really. All right, back to the plan. So I'll give a quick recap of what Neo4j AuraDB free is in a second. If you watch this for a couple of times now, you probably know, but still I'll repeat it. What we usually do here is we pick a data set and explore that data set. If you have a data set you'd like us to explore, let us know. You can reach out to us via Twitter, via Discord, via the community forums, via email. Anything goes really. I mean, whatever you see and think, okay, this would be cool, or something you have. Let us know and we can have a look at it and see if one of the next episodes we can talk about it. Generally, I mean, today might be a little bit different though, but the topic is we pick a data set, we think a little bit what kind of questions we might ask, what would be a interesting outcome of the data set, and then determine a data model and load and query. Like I said, today we might do it a little bit differently. What is Neo4j AuraDB free? So this is the free version of Neo4j AuraDB, which is the database, graph database as a service offering from Neo4j. And you have basically everything you get or you need to start your project with a graph database and in one place. You get Neo4j Bloom, which is the visualization platform, as well as the browser, which is the development tool we are usually using, and you'll see definitely browser later on. It's free forever, so you register once. You don't even have to put in a credit card or anything else. Just register, and then you get access to it, and then you have one instance for you for forever. The only limitations really are that it is that the size of your graph cannot be more than 50,000 nodes and 175,000 relationships. But that's plenty to try it out, to give it a spin, and to see
Yeah.
what you want to do, and if this is something you feel is interesting for you. If your data set grows, you can always upgrade AuraDB free into the next tier, which is then obviously not free anymore, but still you have it there. I'll post a link in chat in a second, so you can see where it is and what it is. And yeah, today world borders is the topic, so we want to discuss this a little bit. So yeah.
Cool. Thank you, Alex. Yeah, and interestingly, world borders are definitely not a static thing, so they change all the time. And when I was looking for a data set, I actually found one book. Let me see if I can still find it. Ah, here. It's kind of a Civil War research data, and they have a borders, like a disputed borders data set where they basically also capture from when to when is this border kind of valid. So like they even have like the
Okay.
time information. But unfortunately, they don't have all the countries, only like the disputed borders. So that's why I didn't pick that one. But if people are interested in it, I can put it into the chat as such, which was interesting.
Yeah, that could be interesting. Yeah.
Let's see. Let me send it to you in the chat, so in the private chat, so we can, because
Yep.
otherwise I need to log in first into.
Yeah, no worries. I'll
Cool.
later.
Super. Otherwise, I actually got reminded of this because I saw I knew that there was a graph gist for this topic. So this is, by the way, the dataset Center for Study of Civil War. I couldn't immediately find their current page, so I just went to Internet Archive because another book pointed here. And then anyway, but they also have a current page. So if you search for that directly, then you'll also find it as well. So what I remembered actually is there is an GraphGIS, and I don't think that we have talked about GraphGIS much, but they are really
Not so
cool.
much, no. Yeah.
They're really cool, cool source of data sets, and that's why I want to spend a few minutes or a minute to talk about them in general. So for a long time now, for I think since 2011 or something like that, we had this ability for people to contribute their example data sets in the form of an basically annotated text file where, for instance, if you pick this Northwind one here, in the text file you have basically some text, explanation, images, and data models and so on. And then you can have embedded Cypher queries that run against an in-memory database of the system here. So it basically shows you how to model a data set, what are considerations, and has example data sets. So much like in browser guides that we looked at in the past as such. And there are quite a number of these GraphGIS. So they are like, you can search them. So they are kind of featured ones, as you can see here, all kinds of different ones. But then you can also explore them by use case, by industry, and so on. And you can even create your own. So we have a portal for creating them and maintaining them. So they are easy to create and basically just a text file, as I said. So for instance, if you take here the one from Adam that we just looked at, if you want to look at the source, it basically is here, as you can see, just a text file with some annotations, and then you have Cypher code in code segments as such, right? So it's not very hard to do. And then you have text again, and then another Cypher query, and so on. But it renders kind of weirdly on my screen here, so I'm not sure. But it's really basic text files, and you can take them and turn them into these interactive guides as GraphGIS. So they are kind of pages on the web that you could use. But recently, we also added the ability to download them as Jupyter Notebooks, which is really nice for people that want to take them and turn this into Jupyter Notebook, where then basically the text is markdown segments, and the Cypher queries are actually wrapped in cells that can run Cypher as such, which is really nice. But what's also interesting is you can put in your database URL here in this one, and click open, and then it opens it actually as a Neo4j browser guide, which is really cool, right? And that's what I wanted to try today, and let's see if this works. And so what I got reminded of was this GraphGIS here, which is called World Borders. Basically, it has all the countries, or a number of countries, so it's from Mathieu to Tate, and it has all the countries, and then basically which country borders which other country, and how long is this border between the two countries as well. So we have basically neighborhood relationships between countries, right? And then you can visualize things. So this is, I think, a Giphy
nice
visualization where you can kind of visualize this data as well, right? And so I thought if I take my AuraDB free database, so if you haven't done this, you can also create your own AuraDB free database. You can just go to neo4j.com/aura or follow the link that Alex shared in the chat. Click on create database, click on Aura free, give it a name like, I don't know, borders or world borders. And then you can say, okay, I want to have a blank database, and you click on create database, and then it starts creating database. Make sure to copy the password so it's safe. Put it somewhere safe because you need it later. And then you continue, and then it takes 2 to 3 minutes to create your database here and get it up and running. I already did this now so that we can get started directly. So here's my world borders database running. And I basically can just copy this connection URL and Where were we here? In the graph, just put it into the connection URL field here and click open. And fingers crossed. So I just need to log in. 1 second. Neo4j. Grab my password from over here that I saved. And then I should be able to connect. And then I have this
Wow,
this
this is super
graph just
easy
as a
then.
browser guide. Yeah,
Yeah, wow, this is
really
nice. I
nice,
didn't know
right?
that this is
So,
possible now. This is
and
great.
with all of them, right? So not just
Yeah,
for this one, but all of them, you can run them as browser guide, which is really nice.
super good.
So,
Yeah.
and this data set basically creates all the countries, as you can see here. All the names are in French because Mathieu is French and he needed it for something, I think. So we might have some fun finding the right countries.
Yeah,
But I think it should be fine.
yeah,
And
it's close enough.
after the countries, it actually connects them with a borders with relationship with the length of the border between these two countries. Right?
Okay.
And so we can just run the statement as such. Let's see if this works. Okay, that's it. 158 countries. So it's probably not all of them because I think nowadays we're at 176 or something like that. But at least this gives us an understanding of what this could look like, right?
Yeah.
And now we can explore this. So first of all, we could just look at the data. So we could click on the country nodes and have the countries here as such. If I do style reset, then we also get some color. So the countries are now purple here.
Purple, yeah.
And we can also click on the borders with relationship over here. And then we see which country has which border of which length with other countries as well. So these are only terrestrial borders as such,
Yeah,
right? So
makes sense.
not
Sea
borders, maritime borders, exactly.
or
So
rivers
to
or something
visualize,
like this.
exactly,
Yeah,
to visualize a little bit the borders, we can also select the border here in the side panel and say we don't want to show the type because it's always borders with, but the size, so the length of the border, so we can actually
okay, yeah.
see how long they are. So we see some of these borders, how long they are. Actually, you should do this in Bloom later on to actually visualize it with the
Yeah, in Bloom you
width
can
of
see
the
it better. Yeah.
and actually, what we should also do is we can add them up per country because currently the countries don't have any additional information. They only have like their ID.
Idea and
But
name,
what
yeah.
we can also do is we can add them up per country so that each country has like the total length of its border as an attribute as well. Right. And so now we can see, for instance, if we find a country where c dot name. I always misspell Alemania in French, so my French is not so great. So let's see if we find Germany. Here's Germany in French. And now we could visually expand this and see what are all the borders. And Germany has actually quite a number of terrestrial borders, right? So from France to Czech Republic, Switzerland, Luxembourg, Austria, Poland, Belgium. I think that's also a short, like 160
That's a short one, yeah.
kilometers.
Short. Netherlands.
That's Netherlands, right? Denmark. Yeah, and so kind of quite a number of borders here, right? So we also have Sweden, but I think that's only like a sea border, if at all, or if that's kind of outside of
Sweden
the
is,
zone.
yeah.
But usually it's quite a number of. So and then we could go from here and say, okay, who then kind of, for instance, France borders with, and then we see, okay, there are some shared borders between France and Germany, of course, right? So with countries that both border with, but then there are also separate borders like to Italy, Spain,
Andorra,
and some others.
Suriname, I don't think so.
Suriname and Brazil. I think that's from the French territories. It could be that some of those are from the French territories, like French Guiana and others. Right? There might be the territories inside of that, right? So, or if you look at Italy, so Italy probably has also then Austria and Switzerland, and San Marino as well, right? And the Vatican has a
Vatican,
3 kilometer border with Italy as well,
yeah.
and to Slovenia. Right. And so we can explore this data set from here, but we can also, of course, query this, right? So if we don't want to visually explore this, we could also just say, find us the country and its neighbors, for instance, right? So, and then return country and neighbors. And if we do this, oops, let me add the relationship as well. So we see Germany and its neighbors. Right? So, but we can also continue this. And so if we don't return the country and the relationship, but we assign this to a path, then we could return the whole path of this graph pattern here. Right? And then we could also say, okay, what's the second degree? So around Germany, right? So what's the second degree pattern? So what are the neighbors as well, right?
Yeah.
And then we get probably almost all of Europe as such, right? So so we have Germany here again, Switzerland, then from Poland, the neighbors of Poland, like the Lithuania and Latvia and Russia and Belarus as well, and then, for instance, from Austria, Hungary, Slovenia, right, and so on. So we see basically the second degree, and so we could continue from here and say, okay, if you want to have 3 degrees, actually we can write this shorter by just saying, okay, this is like distance 2, and then if you want to see distance 3, we would just say distance 3, and just spell out the length of our path with a star and a number of hops that we want to follow, right? And then we get the whole path here as such, right? So that's kind of one option that we can do. We can also look at kind of who's the most connected country. So for instance, you could say, okay, let me just, we can use the same. So we can find all countries and return the country name and the size of how many borders do they have, that country have, does this country have, right? Border with, and this is our degree, and then we order by degree descending limit 5. So we see Russia has 14 neighbors, China has also 14, France has 11, probably because of the territories.
Because of the overseas,
Yeah, Brazil, and then Germany is already on position 9. I'm surprised by that. So that's
that's a lot. Yeah, but makes sense. And if you think about it, it's just around
in the middle.
in the middle, exactly. Yeah.
Or we could do also
no, I was saying if you think about it, it makes sense because of all the neighboring countries here in Europe and the countries being all that much smaller. But then thinking about it, only China, which is a huge country, Russia, which is a huge country, has five more neighbors. So it is actually quite dense.
Exactly. So as degree, and then if you look in the other direction, which countries have only like one neighbor or so? There's Haiti, which is an island, so an divided island, basically. Vatican, Monaco, Dominican Republic with Haiti, right? So Timor and right. So
it's also a divided island, more or less.
Also divided. So I think Cyprus might also be there as well, right? And
Cyprus, exactly. Yeah.
Right. So there's some. There it is. Right.
So the next one. Yeah.
So you see that kind of we have. It's a kind of quite broad distribution, and actually Canada also has only one. That's interesting.
Right? It's a land, the only one land border, right? I mean, there is probably via
more to Denmark,
to
Greenland or so, right? Yeah, and then. And then I mean because Alaska is Russian, Alaska was Russian, is now American, but to Russia there's Alaska in between, right? So that's
exactly
why and it's also not a land border as well, right?
It's not exactly.
So the other thing that we can
this island, I don't know, I can't right now exactly tell the stories, but I think there's this one island somewhere in the Antarctic somewhere, Arctic Circle or something, that is kind of sort of disputed between a couple of countries. And I think that the Danish are involved and the Norwegians are involved, and I thought the Canadians also. And what they
Yeah,
do
could
is
be.
they usually plant their flag and saying, "Oh, now this island is ours now," and put a
Mm.
bottle of local whiskey or something down. And then when the others come around, they remove the flag, put in their flag, and put another bottle of alcohol somewhere again, and
Yeah, it's
it
probably
just
somewhere between
goes around
Greenland,
again.
somewhere here also, right? So there might be somewhere here in the middle between Greenland and Canada or something like that, right?
or
So
yeah, somewhere there, or
somewhere
even
here
further.
where the passage is controlled or so, right?
Yeah.
So that might be.
So
Yeah, I also saw today on the news that there is this. Where is it? Where are we? Here. This is Canada. And actually, there's an only 2.5 mile distance between Russia and the US, between these two islands. This is American, and this part is Russian. So it's
okay,
55
that's close.
miles
Yeah,
on across the Bering Strait, right?
yeah.
But it's between these two islands, it's only
These
like 2.5 miles or
so
something like that
the
distance.
border goes
That's kind of the
right in the
closest.
middle through these
Yeah,
two.
exactly.
Okay.
I guess they are probably also kind of somehow disputed, but
Yeah. Well,
it's exactly. So the other thing that we could do is we could also sum up the length of the borders, right? So we can say we don't just get the size, but we also sum up the length of the borders as well, right? So what we can do is if we move this up here, our border from the country,
yep.
we just count the number as degree. So that's kind of the alternative. And we can sum r dot size, I think it is, as length. And then we can actually sort by length descending. And then see who has the longest borders, right? So we again see China and Russia, but also Brazil has a very long border, of course, right? And India,
India,
right?
United States, obviously. Yeah.
Yeah. Kazakhstan, that's kind
It's done,
of
yeah.
surprising. And Congo has
It,
also a really long
yeah.
border. I
So
thought
a couple of
Chile
these.
has a longer border, but Chile has only like one side is only
It's yeah. The other one is ocean.
land
Yeah.
border.
Yeah.
Yeah.
I guess Kazakhstan is a big country, and
Yeah.
Congo also. You always, I mean,
Yeah.
I don't know. I tend to forget sometimes about these how big these countries are,
Yeah.
and then this is a good reminder of the size of some of these
Yeah.
countries. Yeah.
I think people also have often pointed out that the different map projections often give you a wrong impression of how big the countries are for real,
Yes.
right? So
Yeah.
and so depending on what map projection you use, the countries appear very different in size. And
Yeah.
recently there was something where people showed that Russia actually fits into northern Africa, for instance, right? So
Mm.
in terms of like just the square miles or square kilometers, right? Just the area, and so it's just the projections question as well, right? How big we perceive actually
Yep.
countries to be, right? And
Yep.
depending, sometimes there's also used for political reasons. Kind of, if you want to show your country in a very favorable size, then you pick a projection that's more
It's true.
favorite to
Yeah.
that.
Yeah. But that's a good point.
Um,
You look at this atlas or at this map, and then you think, okay, this is what how it is, and then you realize actually
yeah,
it's different if
exactly.
you yeah.
Exactly. So what I mentioned before, we can actually do here in our query because we just had this here as well. So we can actually set the total border length as a property as on the country as well. So we can just set c dot. Should we also call it size? It's not really size, right? It's
Border length or something.
yeah. Let's call it border equals length. So now, oops, width. So it sets the 158 properties, and if we now look at our countries, they all should have a length property as well that we can look at. Right?
Yeah.
So now we could also look at other things basically. But what I want to do is quickly look at Bloom, because I think now that we have the data in there, we can also visualize this nicer. Let me just grab the password again. Neo4j Bloom is a really nice interactive visualization tool. We should probably also create an index for the country name. Where's my database here? Create index on country name. And probably need to refresh this so that it gets the index as well.
Just to be safe, yeah.
So, see, and now we can just type the name of our country and basically explore it like this, right? So we have Germany and its neighbors, and then we can say the neighbors are here, and so we can find things like this. And what we can do in Bloom now is we can actually visualize both the borders as well as the countries based on their border size. So there's this rule-based styling. We can add a rule-based style for border, and here we already see there's quite a range in this histogram, like from 4 kilometers to 20,000 kilometers, right? And we could say we want to size this basically between those, right? And then if I click apply size, then it basically apply the sizing rule, and we do the same for the relationship.
Yeah.
Here, rule-based styling on the size key, range, size, apply, and let's say we make it also really thin to 4.x, really bold. So this should give us visualization where we see, okay, which countries have a lot of border, which countries have only short borders like this here, San Marino. This is Russia? This is weird. This should not be.
No.
This has 20,000.
Did we do it in reverse, maybe?
I can't imagine, but let's have a look. Notes. Min point, midpoint.
No, you need to go. No, you're in color. You need the size.
Min point is 4. Max point is 20,000.
Interesting.
Perhaps we found a bug. This is weird. I have not seen this before. Let's see if I take 2x only as.
No, still.
There's something really weird. I've not seen this before, so there seems to be something.
If you try to make min point like 1 and max point like 21,000 instead. No.
Something didn't work here. So you need to probably see what's the reason why is this not working. But this must be new, so because until now it always worked. So I'm not sure. I'm not sure what it is. Okay, what I also wanted to show here is that usually with let's basically remove the sizing here. What I also wanted to show is if you get all the countries, basically, we can, if you're lucky, you get basically an styling that kind of more closely resembles the geographic. So it's probably not 100% because it's a little bit too narrow here. But usually what you get is that because of the neighborhood relationships, things that are related are also placed together. So this is closer than it used to be. But what you usually get is kind of these things layouted in a way that they actually resemble the geographic relationships, right? So because if you have a neighbor, then they are the neighbor on the map, but also in the graph layout, they are also your neighbors basically as well. So, but here it kind of overlaid everything. It could be because of some of the colonies actually that it created these.
Yeah, that could be it.
Right. So for instance, here, if you now have South America over here, right? So then you see actually that you have Peru and Venezuela and Chile and so on. So, but if you arrange them a little bit, then you actually see that it's kind of showing how they are related as well, right? So you have some of that happening as well, right? So unfortunately, it doesn't show as well nicely as I wanted it to show, but at least here for Latin America, you see that it goes like Colombia, Panama, Costa Rica, Nicaragua, Honduras, Guatemala,
Yeah.
Salvador, right, and then to Mexico and Belize, and then United States and Canada. So here you can actually imagine a little bit for Latin America, and then for South America, if you sort out the borders, then this actually could use a filter. We could use a filter and filter out short borders. So if we take only borders that are like at least a few hundred kilometers or something like that. So apply filter, and then we can dismiss these elements. Then you probably see more of those relevant borders as such, and so this should give us a better visualization as well. Right. So here, for instance, Europe with the different Bulgaria, Hungary, Slovakia, Poland, and so on. Yeah, so we should probably not use the very, very short.
At least you can see a couple of the clusters, right, by continent, sort
Yeah,
of.
yeah, exactly.
They form together.
I've seen this looking quite nicely in the US with the US states, actually, that if you just visualize them as a graph visualization, then you get those as well. Okay, cool. So this was probably mostly what I wanted to show with this data set. But what I also wanted to do is basically to see, can we reconstitute something similar from a raw data set as well, right? So let's clean out this detach readn. So let's clean out this database. And I found this page here, which is called from Open Datasoft World Administrative Boundaries, Countries and Territories. And this has also data about countries and not in the format that we just had, but it has the coordinates as a geocoordinate
Okay.
representation, right?
Yeah.
And what I thought we could look at, first of all, we should actually get the total border length for a country. That's something that we should be able to compute. Let's see how well this works. And then we also see some of the territories and things like that. And perhaps you're able even to, with shared coordinates, can figure out neighbors, basically. So which are countries that share coordinates, basically. So let's see how far we get. And I wanted to play around with this and see how far we get here.
Yeah, cool. Maybe that's possible. That would be interesting. Yeah.
You can download this as a CSV file or JSON or Excel file. So we can also put this into our chat as well.
Do you have?
I'll send it to you, Alex, so you can paste it in. Thank you. I put this CSV file into a GitHub gist over here. So we can use that basically to load into Neo4j, which also kind of gives us a little bit of how to load data into Neo, right? So basically what we want to do is we can say load CSV with headers from, and then paste in our URL. So we can't use this GitHub URL, but we would use the raw URL. So if you click on this raw, you get like the raw CSV here. From this as row. This is kind of our CSV row, and then we have to do say field terminator semicolon, because that's what they also say here in download, that CSV uses a semicolon as a terminator. And then we can just return row limit 5, give us 5 rows basically of the data. right? So we have
Okay.
San Marino here. These are the border coordinates. Have the English name, continent, region of the territory, and the French name as well, and the ISO code, right?
Yeah. Okay.
And the geo point of the country, basically, I don't know. I don't know if this is the capital or just like a center point of the country, but we
Maybe
can
it's the
still
center
use
point.
this.
Yeah.
We can still use
But
this as well. Yeah, and so we need to remember the 43. So the first value in this one. So actually they're flipped around in the two places, right? So here the first value is the latitude, and the second value, the 12, is the longitude for the geo point. And here it's actually flipped around, where the
great.
where the longitude comes first and then the latitude comes second. And that's always, I always mix this up, and
Yeah.
I always have to look it up. But let's see if we can get this going. So first of all, I would say we can create the node for the country and create the geo coordinates for the country itself, location. And for the border, I think what we can do is the following. There's an epoch function. It's called epoch convert. So this is a JSON as a string, right? So it's an GeoJSON just as a string. And there's an epoch convert from JSON map, because it's a JSON map. And then we say just row dot. And because these headers have spaces in them, geo shape as geo. So we get, this is our original row, and this is the coordinates thing here.
Mm-hmm.
And we see that this has like a coordinates field, which we'll pick. And if we load this, then we get a list, a double list actually, because there seem to be multiple polygons possible. And we could just pick the first one. So I think for islands also, they have probably multiple polygons as such here. Right?
Yep.
But if we pick the first one, then we have a list of doubles here. So what we could do is we could probably say, okay, we concatenate all the polygon lists together. So that's something that we can decide how to do this. But at least it gives us the ability to have all these lists here, the polygon lists as such. So I'll just for ease of use, I'll just pick the first one for today. But of course, it would be more correct to concatenate them all together as such into one long list. As such. So this is our border geo, and then this is the other data. So what we now can do here is actually create a node. So we can just say create or merge country, where we say name is, or we say ISO is, we want to take the 3-letter ISO or the 2-letter ISO?
SMR was the 3-letter ISO.
Yeah.
SMR.
So row dot this. And then we say set c.name equals English name.
English name, yeah.
So you see that I need to use the backticks because there are always spaces in here and so on, right? So then we can, we could set
We could even
the continent,
yeah.
but we can actually also create a node for the continent if we wanted to, right? So, and this is the continent of the territory, row dot. And then we can actually merge them together. So we have the country is basically on, or continent. Did I misspell this? It looks a little bit weird. Continent. No.
No, it looks good.
It has a lot of ends.
Yeah.
And we also have the region. We could also say
Yeah.
we also add the region in between here actually. And we connect also the country to the region. And then the question is, should we also connect the region to the continent? We can also connect the region to the continent as well.
Yes.
This is region on continent. Then we probably don't need necessarily the country to continent as well.
Yeah, maybe not.
What else? Oh, and we wanted to set the geo point, right? So we also wanted to set c.location equals point, and then we said latitude is row. Should probably also use row dot geopoint, because this is a string with split by comma. So we just split this already here.
So you split it in
by comma.
Yeah, okay.
As log, and then we say here log from 0. So what is this? 43 is the latitude, and longitude is the 12. So the second part, right?
Yeah.
Log from 1, and then we need to do the 2 float because these are still strings after we split it.
Okay.
Okay. And then, so this is the location of our country. And then we also have the border, right? c.border, which is our list of coordinates here, right? And here we basically need to go over the list of coordinates, and each of the entries we need to convert into a point as well. So we do the following. We say, let's say point in geo, and then we convert each point into a point. Again, with latitude. This time the 12 is the second thing, right? Not the first one, like in the other one, right?
Yeah.
So
exactly. Yeah.
So latitude is the point of 1, and the longitude is point of 0. And so we go over the list and convert each of these pairs of coordinates into a point object. And then we get a list of points basically back. And this is our first entry in this polygon here as such.
Mm-hmm.
So, and I think then we're good to go. Should we try to run this and see what happens?
So you just for clarification,
yeah,
in border,
so let's do this here. So we have the row. We have our geo point as location, the split string, and in this geo shape. Originally, this was like a JSON map with coordinates, and within the coordinates there was a double or actually triple nested list of coordinate points. Right? It's a polygon.
Yep.
And so what I do is I get from the coordinates, from the list, kind of just the first entry, which is the first polygon in air quotes, right? And this is what's in geo. It's kind of the first entry in this double nested list. So it's the first polygon.
Yep.
That's in geo. And then we go over every entry in geo. So this is a list comprehension which goes over every entry in geo and turns then this entry into a geo point for Neo4j. And saves the entry's first value or the second value actually as latitude, and the zeroth value as longitude. Right. And then basically does this for every entry, for the first, for the second, for the third, and so on. So we get a list of points back.
Mm-hmm.
Right. And then we get region, the continent, and is there anything else that's interesting? There's no population also, right?
No, that's
no population, no capital. So this is something like a knowledge graph where we could actually pull in other information from other sources as well. Yeah. Okay, let's try this.
You have a typo at the beginning.
And I misspelled something. Oh, here the N is not correct. So ISO is null. So we have one country which has null as ISO. That's not so nice. So let's see which one this is. With star where row dot, what was it called?
ISO 3 country code.
ISO 3 country code. Perhaps we need to okay, APA. It doesn't have any country code, right?
Yeah, no.
Neither 2 nor 3. So should we then just merge on the English name instead, and hope that we have those at least?
Yeah.
I mean, it's not ideal, but because okay, then let's merge on the name here. Name and just set the country code if it's there. Then we can set it. Set c.iso equals row dot this.
Yeah.
Okay. What? C country. Oh, this. Cannot assign list to field.
Do we need to change to float again here, or is this not necessary because it's a JSON?
No, something is wrong. Cannot assign list of double to field. I must have misspelled something. So this one is latitude to float from this, comma, longitude to float from this, so this should be okay. And this one is latitude 0, longitude colon point this. This looks okay. But for whatever reason, this is now a 2-element entry here. Interesting. Oops. Let me comment this out and then see if this works. Region null. And with where not. Okay, so at least we got some data here now. So we got some regions: Polynesia, Australia, New Zealand. Let's see what's in there. There's continent Oceania and New Zealand, Norfolk, and Australia. And what continents do we have here? For instance, if we pick Europe, then we have these regions, and then we have the different. Okay, this seems to have at least worked as such.
Yeah.
Right. So I'm not 100% sure why our geo thing did not work. So we should actually be able now to also see the geolocations and so on. So from that perspective, what we can definitely do is, for instance, to say, if you pick a country, like let's say where n.name equals Austria, right? So this is Austria, and we have the geolocation. Now we can actually say what countries are closest to Austria, for instance, right? So, and distance. So we this is Austria, and we have another country where distance between n dot location and o dot location, let's say, is less than 10,000 kilometers or 1,000 kilometers. And then we say order by distance descending. So we basically get our two countries here.
Yeah.
and get the distance between them. So we see, oops, is this in meters? Why does this only return one row? And n is not equals O. Okay, so let's output the names of the countries and the distance. I don't know why the filter didn't work. Oh, ascending. I mixed. That was the reason.
Okay.
Because I ordered them. Okay. Anyway. Okay. So we have from Austria to Slovenia is 171 kilometers distance. So this is in meters, obviously, right? So that's why my distance was also a little bit too low. So from Austria to Czech Republic is you can probably divide this by 1,000 or something like that, right? So we have by 1,000. So that's kind of our distance in kilometers, right?
Yeah.
And so that's where we see, okay, what are the neighbors of Austria here as well, right? Or which countries are close to Austria. So I'm really sad that our loading didn't work for these geo things.
Yeah, don't
because I really wanted to try out to see if we can compute actually the length of the length of the where's our load CSV here? The length of the border here. Perhaps we can say, if I run this again, it doesn't like me, but what we could probably do is we just try it for the first 100 or something like that. No.
And you just said it afterwards. Or? No. Oh, maybe, yeah.
It complains again. So, but for each point in the geo, so geo is our, we had this here, right? Where's our geo thing?
Yeah. No. Yeah. Here.
Here. So this is our, let's look at this again. Geo limit 10. So geo is a double linked list. So for each entry in this list, there are only 2 elements in here. And for whatever reason, oh, here it's a 3-element list at the end. I don't understand this. Why this is a 3-element list here. Can you see that? This is like, some of these lists are 3-element. So 1, 2, 3. Let's say the first 3 work. I'll need to figure out what the issue is with the other ones. So let's just try the limit 3. So our first 3. So for instance, San Marino should now have an where C dot ISO equals SMR, return C. So this is the Marino, and it has this border list here now of points, right?
Mm-hmm.
And what I wanted to do is actually to compute the border length before we have to close, because it's already 11. What we can do is basically we can set C dot length. We just go over the list in pairs and compute the distance between each 2 points, basically. Right, and then this should give us the distance between, or the length of the border as such, right? So if we go over sum equals 0, and then we just say index is range of 0 to c dot border, the size of this, -1. So we get to all the points. I think the first and the last point are the same. 12049 and 4930908. Looks pretty much the same. So in Polygon, I think they repeat the first point at the end again. So we go from the first to the last point, and then we just say this is sum plus distance. Actually, we need to go from here, and then we say just c dot border from index, comma c dot border from index +1. So what's the distance between these 2 points? And then just sum them up, basically. So we go iterate over the whole list here, and then take a pair of current entry and next entry. What's the distance between those as such in meters?
You need to write c dot length at the beginning, right? Not s dot length.
Yeah, thank you. C dot length. So we sum them basically up. And that's our total. We could probably divide it by 1,000 also to have it in kilometers. So, and it doesn't like us. Distance, reduce. Oh, this must be an in. So, float. So now we have the length is 33 kilometers for San Marino, which sounds reasonable, right? For the small, state. Yeah.
Sounds about right. Wikipedia says, does it say something here? No. 61,000 square kilometers. It does not say the border length.
Yeah. So you can probably.
Marino.
Where is Frontier Tier? I think Mathieu had another file somewhere with the border length as well, but I think it should be border length.
Here we go.
How far were we off?
It says here on this page 39 kilometers.
Okay, then we're a little bit off. 39. Okay.
39, yeah.
But I guess still close enough. It probably also depends if you take the sea border or the land border or what kind of the border you take there, right?
Yeah, maybe the first
but
and the
at
last
least
was not the same. Was not.
Yeah,
the
so
same
we need
after
to
all.
check this. Yeah,
Yeah.
and otherwise we would have to go over. Oh, it looks actually 6205. Looks okay.
No, it's
Anyway, but that's kind of how you could be computing that, right? And then usually in a polygon you would take all the partial polygons and add them together as well, right? So not just the first entry for the polygon. For instance, if you have islands with multiple borders or something like that, then you would also want to add these as well. But just to show you how you could do this in Neo4j, you can use you can create an index on the location as well. Create index on country location, which is then a geospatial index and uses kind of space filling curves to represent the geolocations as well. So you can use this as well to do efficient geo lookups as well. Right? You can say I'm here, which countries are closest to me or in order and so on, and this will use the index as well. Right, so there's some good stuff that's happening there.
Yeah, one question from chat. You used APOC procedures, and Jiang says not all APOC procedures are in AuraDB.
Yeah,
is there
true.
a way to find out?
Yeah, so if you go to the Aura homepage, there are Aura docs are linked here, and then in somewhere APOC support. Yeah, in getting started APOC support, there's a list of which APOC procedures are supported in this.
Perfect.
So again, from here, get help docs, you can go to the Aura support docs, and then in Get Started you have it on top level as such.
All right. And if your favorite epoch procedure is not supported yet,
then you can vote for that. So there's also an feedback mechanism here where you can provide get feedback, but also can provide send feedback over here, and then ask for that as well.
Exactly. Yeah. Perfect. Cool.
Super. So now we actually spent more time, so that's cool. Yeah,
That's all
but
right.
it almost worked. So I just need to figure out polygons, so which is a challenge in itself. I think GeoJSON and geospatial data is it's always a little bit tricky, similar
Yeah.
to date and time data as well.
It is a bit tricky indeed, and strange that for some reason they have three or sometimes 3 points for
Or four, right? So
for
it wasn't like
yeah.
it wasn't like a triple nested
Yeah.
thing somehow for whatever reason. I'm not
That is
100% sure
strange.
what that
But
means.
maybe it is because maybe that's how I draw it with the polygons. Maybe then if 2
Mm.
polygons, I don't
I
know.
think
But
there's also something when you have holes in a polygon. So you have like in country,
yeah.
and then you have a cutout somewhere. Then the polygon is actually multidimensional because the cutout needs to be part of that polygon that it's
Yeah, that's
cutting
true.
out of, right?
Yeah.
So if you have like something has a circle, and then for whatever reason it has a cutout region, then
Yeah.
that could be
Like San
the
Marino in
reason.
Italy is a cutout for the Italian polygon, I guess.
Yeah, could be. Yeah,
Yeah.
exactly.
So
So that's something that we probably would have to look at how the GeoJSON here represents the polygon. So I was probably too simplistic, just picking the first one.
no, but I think that's fine.
But yeah,
Yeah.
just for demonstrating purposes.
Exactly. Exactly.
Cool.
Cool.
Sounds good.
Thank you, Michael. I think that was another fun session. Thank you for watching. This week we have a pretty packed schedule for live streaming. So if you are eager to watch more Neo4j live streams, then this is a good week for you, or actually a couple of upcoming good weeks for you. So this afternoon, Central European time, 5 p.m. So in 4 hours, 5 hours, our colleague Florent is talking about PHP and Neo4j. So that's this afternoon going to happen. Tomorrow at 5 p.m. also, I'm talking to Jesus about the second episode of Going Meta is taking place. So that's tomorrow at 5 Central European time. And on Wednesday we have our first workshop, Intro to Neo4j. Michael and I
Yeah.
will be then back to talk about how to get started with Neo4j.
Yeah. So please, if you don't need this yourself, but if you know someone who could benefit from this intro series, either colleagues or friends or family or other folks that you know that have not seen graph databases before, please share it with them, and we're happy to always get new people introduced to graphs and Neo4j. So that would be really cool.
Absolutely, that's the point. Okay, well, with that, I think we're done for today. And thank you for watching, and wish you a good rest of your day. Take care, everybody. Stay safe, and see you soon.
Take care, everyone.
Bye.